Welcome back to Foundations of Data Science for Psychology. Today, we're going to continue our discussion of basic concepts and terms in computing and programming, and we're going to talk about development environments. So what's a development environment? So technically, your development environment is whatever setup you use to write code and interact with your computer, sort of the set of software and processes that you use, that you develop, that makes it easy for you to write and execute code. But we want to teach and make sure that you're familiar with a few key terms and concepts: the command line interface, the concept of a graphical user interface, and integrated development environment software. These concepts are not critical to programming, but being aware of them is going to help you navigate this process more easily. So what's a graphical user interface, or GUI? If you've ever heard people say the word GUI or term GUI in the context of software, this is what they mean. So a graphical user interface is a form of user interface that allows users to interact with electronic devices through graphical displays and icons. So really this refers to any kind of operating system, like on Windows, Mac OS, or Linux, and also most software. So most of what we interact with when we interact with a computer or electronic device is a graphical user interface. DOS was Microsoft's first graphical user interface, a sort of system for allowing people to click around and interact with their computer using icons. Early Windows, any text software, really most things are GUIs, right? It's something that we kind of take for granted, that the way that we interact with our computer is by pointing and clicking on visually presented information in the form of graphics and icons. So this is the way that we usually work with computers. It's the way that we usually work with software, but there's a layer underneath that in programming and in computer science in general that we want to talk about. And that's the command line interface. So the command line interface, in contrast to a GUI, involves interacting directly with the computer through a text-based interface. So most early computing used command line interfaces. So if you've seen old computers and really all there is text, it's just inputting prompts and getting output in the form of text and sort of without any sort of graphical interface, that's what we mean. But we still interact with the command line for certain things when working with our computer. The way that we access this on modern computers is through the terminal. If you have a Mac, and the language that is being used when you interact with the terminal is called bash. Or if you have a Windows PC, it's the command prompt. So this is a command line interface. You can interact sort of directly with the computer using these text prompts, and you can navigate your computer this way. Most people do not do this, but a lot of people who are computer scientists or programmers may end up doing it. We're telling you this because you may need to use the command line for certain tasks, like involving installing software, changing security permissions, etc. And if you install a programming language, you can interact with your computer directly with that programming language through the command line, but that's not really what we're going to be doing now because it's not that user-friendly. I'm going to show you an example of using the terminal, but this is just so that you are aware of it.
So this is the terminal on a Mac. The language that technically you would be giving commands in the terminal is bash. That's not that important, but it's helpful to know. I don't really ever use the terminal, but I can do a few things. So for example, we can change the working directory here. We can navigate to a location on my computer. So here I'm navigating to a folder on my computer called My Folder. I can see what's in the folder. Okay, I have 2 documents in here. I can open one of these documents. Let's open up dsx.docx. So I can open up a document from the command line by typing that way instead of pointing and clicking through my computer. Oh my God, data science is so fun and easy. That's so funny. So most people aren't going to go through the trouble of navigating through their computer this way, but it's something that's possible and you may need to use it sometime.
So this is all just to set up this distinction between the programming languages themselves and how we actually use them. So when we refer to languages like R, Python, or MATLAB, which is a language, we're just referring to the programming language itself. A programming language that's been developed by computer scientists or developers for some specific function, and different programming languages are better and worse at certain kind of tasks and have been refined for doing certain kind of data processes. But in order to actually learn how to program, learn how to code, and use these languages, we need a development environment. And so development environments, sort of at minimum, are software that includes at least a code editor. So this is like a text processor, but for code, sort of the way that you would open Microsoft Word or a text file to write text, something like that, but for code that allows you to actually sort of write in the language. But it also needs an interpreter or compiler. And this is a program that would be part of the software that converts instructions from your scripts, from the language that you're coding it, into machine code or a lower level form so that they can be read and executed by the computer. So this is an important part. Your computer needs to be able to interpret the code that you write, and the interpreter or compiler is the part of the program, part of the software that does that interfacing. You can write code without an interpreter or compiler, but you won't be able to see if it works and it won't do anything. And then some development environments, some software also have tools like tools for writing code, debugging, visualizing things, production tools. And we want to be working with software that includes all these tools. It's way easier until you become very advanced. So when software for developing and writing code in any of these languages includes all of these things, it's called an integrated development environment. So we're going to talk about integrated development environments that go with these languages that you'll be learning. So an integrated development environment is a GUI, so it's a graphical user interface that combines many features and tools needed by the user to write and run code. So these are going to have a compiler or interpreter and some easy to use interface that includes a text editor, a console, which is this area where the code, if it's run from the text editor, where the output of that code is. You can also code directly into the console line by line. It will have windows displaying currently defined variables, packages, libraries that you have installed, sort of to help you manage your environment. And it'll also have a window to display plots, figures, visualizations, help tutorial, other files that the code is associated with. It will come with debugging tools, so it can help you troubleshoot while you're coding, and a lot of other tools to help you code and run your code. So we've chosen a few integrated development environments that you can use to actually help you run this. So each of these languages actually is associated with particular development environment, a piece of software that you need in addition to the language itself to run the code. R goes with RStudio. So RStudio is sort of, there isn't really other software for running R. RStudio is the best. For Python, there's lots of different integrated development environments for coding in Python. We are going to be using Spider, which is hosted by Anaconda. So it's an integrated development environment that's very similar to RStudio. That's why we've chosen it. And then MATLAB is sort of unique in the sense that it comes with the software. So the language and the software are sort of one package, and it's also called MATLAB. For now, we're going to focus on R and Python. So what you should have done at this point, or if you haven't already, download R and RStudio and Python and Anaconda with Spider. We've provided some instructions for how to download all of these things onto your computer, and we'll take a look at what these IDEs, these integrated development environments, look like.